Okay, it's day 8 of our Leetcode sessions. Today I've decided to go. I've chosen the problem that falls under sliding window. This is going to be our next sliding window problem. It's going to be longest substring without repeating characters, and it's a medium problem. Step stop watch, and then let's start right away. Okay. Let's see. We're gonna start timer and read it. Problem. Given a string S, find the length of the longest substring without duplicate characters. A substring is a contiguous sequence of characters within a string. Example 1. Input is S, Z, X, Y, Z, X, Y, Z. The string X, Y, Z is the longest without duplicate character. Example 2. It's only 1 because X is the longest substring without duplicate, and then it goes to like another X, and so it just can't.
Me faltan suéteres. Me falta el azul Nike. Me falta
Okay. Constraints are between 0 and 1000 for the length. So I can just automatically code like if f style length is less than 1, or is it equal to 0, then we can just say return 0. Else if I also have another hard-coded part. Else if s dot length is equal to 1, we can just return 1.
Ese es el que tenía. Oh, sí, entonces creo que sí.
Okay. It's already been 2 minutes. Recommended time and space complexity. I should try to find a solution that only iterates. This is a sliding window, so I can only do it from O of n. So it should be like around O of n time. Yeah, O of n time and O of m space. Where O of n is the length of the string, and m is the number of unique characters in the string. I should aim for an O of n solution time. Okay, let's start the timer again. Let me just look at this. So Z, X, Y, Z, X, Y, Z. Let me just actually put it all on the list really quick. Z, X, X, Y, Z, X, Y, Z.
Ahorita, ¿cómo?
Alright, I'll just do that to make it look like a Z. 1, 2, 3, 4, 5, 6. Okay, since this is a sliding window problem, of course we're going to use a sliding window to solve this problem. And we're going to need to keep track of this. Let me just write int max length is equal to 1 for now. So one part I'm thinking right now is, of course, I'm gonna have a window. We'll start with Z, and then my window should get bigger as time goes on. I don't have a way to check. I need to find a way to check previous elements though, without directly comparing. CX. I can't really find this. Oh. Or can we? If I'm saying, okay. As I'm looking at this window right here, I'm like, Z and X are unique. My idea maybe is to use a hash map. Yeah, maybe I can use a hash map and sliding window at the same time. So like, I'll have a hash map that like maps onto the thing. So I have this, and then we'll just start a key, and then or hash set. Sorry, hash set. Let's do hash set. There's our hash set. And like, first time I'm like, Z, okay, this is our first element. Have you seen this element before in the hash set? And if not, I'll be like, okay, add it to the hash set. Because if we're doing this in O event space, that means that it requires like some other data structure to store it in. It could be like an array list, or in this case, it could be a hash set just to count the amount, or if we've seen it before in our window. So if we have Z, I'm like, okay, append Z there, and now increase our window by 1. And I'm like, X, okay. I've not seen X before. I'll append it to the hash set, and then Y, and I'll be like, okay, Y. I have not seen Y before, so I'll put it there. And then I get here, I'm like, okay, Z. I'm checking, have I seen Z before? And I'm like, yeah, I have. I really have. Oh yeah, as we're doing this, so it's all gonna be like under one if statement. So like if seen in hash set, or I'm gonna do the else part. Else, if it's not seen in the hash set, then we're gonna add elements to hash set. Once we add the element to the hash set, we're going to increase window size, while also increasing what's it called? We'll have like some max length. There it is, max length. And then if I have seen this, I'll be like, okay, if I want to change the window, I'm gonna start changing the window. Maybe I'll still do the left and right pointer thing like I did last time, where I have left pointing here and then like right pointing here. And then once I realize that Z is out of the picture, I'll increase window. I can just like right ++ like that. And if I have seen it, I'm like, okay, left ++ now. Here, I found it. And now I gotta remove remove elements. So I'll put, okay, Z is now gone from the set, and then I have updated so now it's like this. I'm noticing how it says XYZ is the longest without duplicate characters, not ZXY. So we get to this point right here. We remove the element, we're like, okay, now we have our XYZ. And now I have X again. Have we seen X in the set? And we're like, yes, we have. We remove it and remove the element in our sliding window, and we're back here. And we haven't changed max length yet. And then I go over here, and I'm like, okay, have we seen Y before? And we're like, oh yeah, we have seen Y. We have seen Y, so we gotta remove it, and then remove that. And now I'm here. I'm at the last element, Z. I'm like, okay, I have seen Z before. Okay, no, the problem is it hasn't updated yet. Okay. Wait, let me run through it one more time to see something. We have Z. We have X. I have not seen Z, so I'm out of here. I have not seen X, I'm out of there. I have not seen Y, so I'm out of here. Then I get to Z again. I'm like, okay, I have found Z. I need to remove that the rest. Remove that. Do I need to remove the element from the hash set though? Oh, sorry, this should be decrease window. So like decrease window. Slash L++. Do I want to remove element from hash set or no? From here. Okay, let's say I don't. I'm like, okay, let's keep going. Oh yeah, I don't think I should remove it at all because you already, if you saw it, then it's gonna be there already. Maybe not. Okay. And Z, I move Z, and I have X now. I'm increasing it. Oh no, I also need Okay, let me start this over again. We have Z. We have X. We have Y. I put them all in the set, and I have Z again. And once I have Z, I have seen Z before, so I want to decrease my window. So get rid of that. I will keep the element there since I already saw it, and then I'll increase the window again. Okay, so I don't need to remove element, but instead I also gotta increase window still. So I have like right plus plus. So you have X, and I do this again. I'm like, okay, I have seen X there, so I'll just boom, get rid of that. Decrease window and just increase the window again. Oh wait, let me keep track of element. I still haven't kept track of max length yet. So Z. I'm like, okay, have I seen this before? Nope. I'm gonna add it. I'm gonna increase the window, and I'm gonna increase ML. So ML is 1 now. And now next iteration, I'll find. No, I'm checking this. Okay, first I'm gonna check the first element. So I'm gonna be like, okay, there's one. Okay, left and right are gonna start at position 0 and 1. So I think I'm gonna start with that. I'm gonna be like, okay. I'll actually start here. I'll start with 2, comparing 2. Actually, no, I can't because I have to start with Z. So I guess left and right can both point the same thing. Okay, if left, okay, it's gonna be right because I'm comparing right. If I have not seen right, if right's not been seen, then I'll add it. And increase 1, window X. And now I realize, okay, wait. Okay, that should be 0 then. Start from 0. I have not seen it. I'll add X. I'll increase window. So now it's 2. And now I have not seen this Y. So I'll increase window. And now it's 3. I check. I have seen this one. I'm going to decrease that and increase the window. Now I'll look at X and X. I'm like, okay, I don't need that. Oh, I've seen X before, so I can see that. Decrease the window and then increase the window again. And I have Y, and I'm like, okay, saw it again. I can decrease that and increase that, and I saw Z again. I'm like, okay, increase that. And it's gonna be like while right. So that's when right gets to Z, which is 6. The size of this is 7. So while right is left pointer equal to while right is less than size. So once right gets to 6 or size -1, it'll stop the loop. Okay. Well, it's only been 15 minutes. I think I coded a solution already. Hopefully it works out. We're going to set up our left pointer and right pointer and max length. We did the back length. So int left is equal to 0, int right is equal to 0. And do while right is less than size or s dot length -1. If we can create our hash set too. Sorry. Hash set it's gonna be character. Yeah, because we're storing only one at. So hash set character char 3 is equal to hash set. Okay. Now I'm gonna check if s dot char at right actually it's if char freak dot contains. I think that's the method for hash set. I'm not sure. Let me double check that. Hash set Java. contained. It is contained. Okay. So charfreak dot contains s dot char at right. Then we're going to say we're going to decrease windows, so left plus plus, and then right plus plus 2. And then we're also going to say we're going to add an element. If we don't see it, we're going to add an element. So sorry, I think it was just add dot add, right? Yes, dot add. Charfreak dot add s dot char at it's gonna be right. Then we're gonna I don't know if the order matters for increase window or increase ML. So I'm gonna increase I'm gonna increase maximum first, and then I'm gonna increase right plus plus. And then after that, all I do is later. All I have to do is return max length. Let's run this. Hopefully it won't blow up. Yep. What is that? Why is that a colon? What? Okay, sorry. Illegal star of expression. Oh, I'm dumb. I forgot to create a new hash set. Sorry. I'm dumb. There's all these syntax errors. I'm just getting to. Okay. These work. Okay, case 1 and 2 work, which is nice. Case 3 did not work. Your output. Let's use the sketch case. See what's wrong. That's nice that we already passed the test case though, which is really good. I was clearly expecting to just like butcher it. Oop. How do I okay, there it is. Delete that test case. Okay. Well, it's nice it worked for all of these, but not for this. Okay, my output's 4 for some reason. PWQ. So we have PWWQKW. Zero, 1, 2, 3, 4, 4, 5. Okay. Let's trace our code, see what happens. So left and right are currently pointing right there. And now we have our hash set. Let me just have the hash on the side, so hash set. And then the first element, we were like, okay, it's not in there, so we will have charfreak.add p. We found p. And we will increase max length to be 1. So ml is equal to 1. And right plus plus. So now right is now pointing over here. And now we do this again. Right is still less than length minus 1. We're here now. Wait a minute. Let me just check that really quick. Okay, still wrong. Never mind. I thought. Okay, I just want to check something. Okay, right plus plus. Now we're here, and we check again. Okay, if char contains char dot right, does it contain W? No, it does not. It does not contain W at all. So we just say charfreak dot add W. We increase max length to 2. And now we're here. And we do it if char free contains char that it does contain it. So we move left over here. And we move right over here. L still the same, still stays the same. And now I'm looking at K right here. Does not contain it. I see what happens. Look what happens when we have 2 characters in a row that are the same. Or if you have like a situation like this. It finds that K is not in the chart, so it'll append K. It'll add K there. It'll increase max length to 3, but it shouldn't. And it'll move right to the right. But why? How do I not do that? Let me go back a step. So K was never on the list. We're still looking at. Let's go back. Let's do this from the beginning. PW. We input P. You have ML is equal to 1, and now it's there. P goes there, and I'm like, okay. Next one again. It's in the list. So our problem here is we should just skip past the second we find a duplicate. We should immediately move our left and right pointer. And we did. We found the left and right pointer, and we're like, okay, W is not, or sorry, this is after we did the first W. Realize, okay, once we get here, oh shoot, we already see that. So left and right move 1 each. So move 1, move 1. I think I have to add a conditional, like if s dot char at left char free dot contains oh no, I shouldn't put it there. Because after this condition, I'll check, okay, K is not on the list, so before I change max length, I will do if char frequency dot contains s dot char at left, then I will move left 1 more. So left plus plus, or left plus plus. And I will not update max length at all. So if this condition is false, then it will always update max length. If it is true, it will never do that. Okay, let's see what happens after. We have WK, and we're like, okay, that seems fair. And I didn't change max length, and I just increased right still, no matter what. After already appending it, I still increase right to the right. Max length stays at 2, that's true. Now, I will see what happens if we go through this again. So I'm at E now. Has E been spotted in the list? Nope, it hasn't, so I add E. Sorry, K was here already, and now E's in the list. Have I spotted E before? Oh no, I've not. So I add it to the list. I check if the hashtag contains left. It does contain left. Okay, the problem with this is WKE is a valid sequence. Huh. Because if it's a valid sequence, then it'll just put left over here, and it won't change max length, and I'll get a result of 2 this time. But my result is I need 3, right at 3. What? Let me take a step back from where I did it. So let's do it when it's like this. It's like that and like that. I'm like, okay, I've seen K already, and so I'll add it and increase my max length by 1, but it shouldn't. I'll just see. Wait, I need to check if the current left to right pointer contains a duplicate. Because if it isn't, then I'll just like skip it. How can I do that? While let me try something. What if I inside this thing I like remove it? So what is the remove? It's just remove, right? Yeah, just dot remove. So what if instead of doing that, I'm still gonna increase left when it's equal to. I'm like, okay, I found K. I'm like, okay, this time when I put K in there, and I'm like, okay, it contains W already, so I can just increase left and not change max length and increase right too. So we'll just do this. So this time I'll do, okay, if char free without add, okay, we will add it to the list. Wait, no, that's not the first time it happened. Hold on. Okay, I gotta go back again. So let's say we're on this pointer and this point right here. I'm like, K is not on the list. I'll add it first. I'll check if left pointer. I'll check if left pointer is there, and I'll be like, okay, left is it. So I'll increase left plus plus, while also removing it. So I'll do char freak dot remove s dot char. Oh no, sorry, I gotta do that before that. So that would be there. Char at left. I'll remove that, and I'll do okay. Left plus plus. So W is no longer in the list, and I'll do left plus plus, and I'll do right plus plus, and change max length. Yeah, okay. Now we do it again. I'm like, okay, is E in the list? It's not, so I'll add it to the list. I'll check if the char frequency list contains a W. And it doesn't. It doesn't at all. Doesn't contain it. So I'm gonna increase max length to 3. And increase right by 1. 3, okay. Oh shoot. No, I'm here. I'm at WW again. And I see, if I check if char freak dot contains char, right? It doesn't. It doesn't contain it, so it will. It doesn't contain it, so we'll add W to the list, and then check. Oh, does char freak dot contains char dot def? It does contain it, so then it'll remove it again. Increase left plus plus, and then not go right, and then right plus plus, and then right plus plus ends up being equal 5, equal to 6, and 6 is can't be less than. Okay, that works. Wait, I don't know if it'll mess up the other solutions though. Oh, let's try this. Oh, and I got all of them wrong now. Well, this is a shame. Why am I getting all zeros? It's because this condition is never true. Oh, what did I create for myself? What did I just create? Also, I unpaused it by accident. What did I just create for myself? Let's run it back one more time. Hash set. Okay. Left and right pointing the same thing right now. And first I'm like, okay, char freak does not contain it, so I'll add right, so it's P. Oh, that's not good. It immediately says, because char left is equal to, it also just remove it and increase left only. Oh, and oh my god, oh, that's so annoying. Oh my gosh. Throughout the loop, every single time, left and right are always at this point sort of the same thing. So no matter what, it's just gonna keep adding the element and removing the element and never increasing max length. So that's what's happening. So to solve this, I might just do right equal 1. I might do that. So it'll change the whole setup. So left and right, I'll start right here. Yeah, but that doesn't work. If these two are both in the same object, it makes things much easier. If that another conditional. If okay, it's gonna be messy conditional. If left is equal to right, and I'm gonna do like an else statement after, and I could just paste that right there. So just that. Oh boy, this is one messy loop. Oops. If left is equal to right, I will make sure to oh wait, I forgot it. I'll first make sure to add a P and it's still 0. Why is it still 0? Oh, my code's getting really messy. What's the hint? It's a big for solution. I don't need that. Okay. Let's start over with that. Let's look at that hit. We can iterate through the given string with index R as the right bound and the left as the left bound. We use hashes to check if the character is present in the window or not. Now we encounter a character at index R that is already present in the window. Okay, that's kind of what it does right here. So if I don't find, oh no, when we encounter index R that is already present in the window, we shrink the window by incrementing the left pointer until the window contains no more duplicates. We remove characters that are clear from the room. So do we need like a while loop in here? Another while? At each iteration, we update the result with the length of the current window, R minus 1. So while some condition may increment left plus plus, this is not gonna work. Or is it? No. Oh. Char at left. This is not gonna work though. Index out of bounds. Okay. I'm gonna look at the solution. Hopefully, I can see what it is.
Let's solve Leetcode 3. Longest substring without substring that we're gonna learn. Once we get to this next fundamental technique, the sliding window. Let's actually, substring is always not containing any duplicates. So once we get to this next A, we're going to say, well, now we have two A's. So we need to start removing from the left. We need to start shrinking our sliding window until we no longer have duplicates. So I'm going to say remove this one from our substring. Now our substring runs from here, from the B, all the way.
Just increment left while also removing problem is that's a problem though. If we remove it, then we won't be able to see it again.
To the A. Now it's perfectly valid, so now we can keep going. It's still only length 3 though, so next we're going to add this B. But wait a minute, now we have two B's. But my question is, how would we even know instantly whether we had a duplicate or not? Well, we can use a set for that. Sets will only contain one of each character, so we'll automatically know if we have a duplicate. We can check it instantly. So we're going to check that we have two B's, so now we're going to keep popping from the left. We're going to keep shrinking our window from the left until we remove a B. And we're going to see that the first one we remove is the B, so now we're done. So now our substring runs from this C all the way to this B. Now we're going to add another character. Once again, we have a duplicate. And once again, we can literally just remove the farthest left character, and now we're valid again.
Wait, no, that one's before that.
No more duplicates. We're running all the way from A to C. Next, we add a B. The interesting thing about this is that now we have to remove this A because we have to shrink our window. Our substring has to be contiguous, so we have to remove this A. But notice we still have two B's in our substring, so we got to remove another character. We have to remove this B. So now our substring runs from C to B. So we are valid again, but now our substring is only length 2. Next we'll get to the last B, last character we're adding, and see, yep, it's a duplicate again. And don't forget that as we're removing these characters from the left, we're removing a C. We're not just removing it from our window, but we also have to remove it from our set, because our set is going to correspond to all the characters inside of our substring that we're at. So we have to remove our
Okay.
C from the window and move it from the set. We have to take this B and do the same thing. And now we have no more characters to add. With this sliding window technique, which is a very fundamental technique that you'll probably see a lot more in a lot of different problems, we can cut the time complexity down to big O of n. We just have to go through the entire list. Well, we might have to add and remove values from our set, but that's a very quick operation. The memory complexity, because of our set, is also going to be big O of n, because potentially every character in the string could be unique, and we'll add all of them to our set. And I didn't really show it while we were going through the problem, but we would want to maintain what's the longest substring we found. In our case, it was obvious that the longest we found was of length 3. So remember, the first thing we need to do is get a set to make sure we have, and we're going to do a sliding window, so our left changing it. So look at character that we just visit at the right point. Characters take the left character and remove it from our set.
Okay, so I do need a while loop. Oh wait, oh that's cool.
So character set dot remove the leftmost character.
Oh yeah.
And then of course we have to update that left pointer, increment it by 1. And we're going to keep doing this while that duplicate remains in the rightmost character to our set. We know for sure that our substring doesn't have.
So I don't need an if statement right there. I can just do that, do that, do that, do that, do that.
Have any duplicates, we can potentially update our result variable, which I never declared, so let me declare it up here. Result is initially going to be 0, and now we can update our result, so we can potentially make it larger than it is if the current window size is greater than what it is right now, which we can compute by right minus left plus 1.
I just do math.max. I guess I use math.max a lot, so like. Char freaks. What? So yeah, that does work. Yay. So I overcomplicated my answer in the first place. It's kind of sad. But I guess he really did sum it up well. I looked at the solution, and I think it's the first time I ever had to look at the coding solution. which kind of sucks because I got way too lost in my debugging. So I did need 2 while loops, and then this one I'll be like, okay, while it contains some character at the right. If the set contains a character at the right, then I need to remove all the ones in the left until I get to that character in the right. So yeah, that's it for today's stream. A little bit long, but it's alright. We keep going. Alright, I'll see you guys in the next stream tomorrow.